We're going to be looking at trig inverses. Well, first let's see what's going on. Suppose y equals sine x. Let's get some points on this graph. Remember, it goes left to right forever. So this point right there, that's 0, 0. So this is going to be pi, 2 pi, and these will be half pi and 3/2 pi. So let's keep a list of the points. 0, 0. The highest value is 1. So that's going to be 1/2 pi. The next point here, the point before is going to be 1/2 pi, 1. It's going to be half pi, 1. This point is going to be pi, 0. The next point is going to be 3/2 pi, -1. And this point here is going to be 2 pi, 0. And this point, let's see, that's negative pi. This is -1/2 pi, -1.5 pi, and then finally -2 pi. So this point here, the x value is -pi/2. The y value is down here, it's -1. This one, the x value is -pi, the y value is 0. This point here, we just did. This point over here, the x value is -3/2 pi, and the y value is up here at 1. This last point, -2 pi, 0. Now, let us switch the x and the y's. If I do that here, use another color so we know they're different, I get 0, -pi. When I switch those two, I get the same. When I switch these two, I get 1 pi/2. Those two, I get 0 pi. These two, -1, 3/2 pi. These two, I get 0, 2 pi. Those two, I get -1, -pi/2, and those -1 minus 3 pi/2, and 0, -2 pi. Let us plot this. So, looks to me very clearly that the x values 0, 1, 0, -1, they go between -1 and 1. So -1, 0, 1. And the y values, they go from 0 to -pi all the way up to 2 pi. In fact, they go forever. Okay, so 0, so like I said, x's go from 1 to -1 to 1. Except, remember, we called those y's. And this became x. We switched x and y. So we have 0, -pi. That's here. We have 0, 0. That's here. We have x is 1, but this is pi. That's 2 pi. But we only go up half a pi. And then 0 pi. That's right here. And then -1, 3 pi/2, 1.5 pi's. that goes there. 0, 2 pi, that's up here. -1, negative pi over 2, that's right here. And basically what you get is something that looks just like this. And it repeats forever and ever. Now, the problem is this is not her function. If I give you this value, and I remember, for a function you plug in one independent variable and you're supposed to get back one dependent. Well, I'm getting back multiple answers. Remember, this goes up forever. It goes up forever. It also goes down forever. This is not our function. This is y equals the sine inverse of x, except it's not a function. Well, we want to make it a function. We want to make this a function. Well, one way of making it a function is we can just keep this piece. We can just keep that piece. Okay, that's going to make it a function. I mean, if you wanted to, you can keep this piece and this piece. That would make it a function. But we definitely don't want the two pieces to not be connected. And we wouldn't like it to be way up here. We wouldn't like it to be way up here. We like it to be centered around the origin. And that means is that we keep this portion of it. And this portion goes between negative pi over 2 and pi over 2. What we have is the following. Y is equal to the sine inverse of x. This means that you can interchange x and y anytime you want. But then if it has an inverse, you don't put an inverse. And if there was no inverse here, like if you had that, you can interchange x and y's, but then you have to put the inverse. Now, that's what I wrote for y equals sine inverse of x, means x equals sine y. This is not enough. You have to say and y is in between negative pi over 2 and pi over 2. Otherwise, there will be more than one answer. Now, I'm not going to derive it. I'm not going to derive the other ones for you, but here they are. Y is equal to the cosine inverse of x. This definitely means you just switch x and y, and you drop their inverse. But then there is this restriction. For cosine inverse, the angle can go between 0 and pi. They always go pi units. From 0 to pi is 2 pi, from negative half pi to pi over 2 is half pi. Y is equal to the tan inverse of x. This means, yes, that x is equal to the tangent of y. And to get back a unique answer, we have to say and y is in between negative pi over 2 and pi over 2. Just like sine inverse. Negative pi over 2 to pi over 2. When it comes to y is equal to the secant inverse of x, well, to get rid of the inverse, just switch these. It means x is equal to the secant of y. But then you have a constraint for this to be a function. For secant inverse to be a function, you have to put a constraint on the angle. You take secant of angles and you get a number. This is a number, that's an angle. And secant, it's going to be that y must be between 0 and pi. Cosecant inverse. Cosecant inverse of x. This means that x is equal to cosecant of y, and y goes between negative pi over 2 and pi over 2. And for cotangent inverse of x, well, of course, this means that x is equal to the cotangent of y. Why, of course? Because that's what you do to get rid of the inverse. You interchange those two arguments. So you get x equal cotangent of y. And just want to think for a moment. And y goes between 0 and pi. Now that we know this, we can play the game. We could solve some trig inverse problem. The first problem that we will do after making these definitions is the following. Suppose that y is equal to sine inverse of 1/2. Well, this means that 1/2 is equal to the sine of y. But there's a lot of y's that give you the sine of that y equals 1/2. Here's the sine graph. It goes forever and ever. And here's the vertical axis. Well, let me put it here. Well, it equals a half here. So here's the half. Equals a half here and here and here and here and here and here. So we can't let all of those answers be y, because then it's not a function. You put in one input, you put in one value in here, you want to get back one y. So we restrict y for the sine inverse between negative pi over 2 and pi over 2. Now, this is quadrant 1 and quadrant 4. All the trig functions have quadrant 1 and another quadrant. Quadrant 1 is always positive. Sine, cosine, tangent, all 6 trig functions are positive. In the other quadrant, it's going to be negative. Well, since we want a half, we know that our answer is going to be in quadrant 1. And the sine of y is opposite over hypotenuse, 1 over 2. And you should recognize this right triangle. 1, 2, square root of 3. And opposite 1 is 30 degrees, 180 over 6. So y is equal to pi over 6. That is your answer. The sine, so if you interchange these two, it says that the sine of pi over 6 is their half, which is correct. And the angle pi over 6 is in between negative pi over 2 and pi over 2. negative pi over 2, it goes up to 0, because 0 is smack in the middle of those two numbers, all the way up to pi over 2. Yep, that angle right here is included. So that's the answer to that problem. Suppose you were given that the tan inverse to evaluate this. That means call it something and figure out what that something is. Now, square root is 3 over 3. When it comes to trigonometry, personally, I think 1 over square root is 3. Let's even make, okay, so we know that this is equal to y. You can interchange those anytime you want. So the tangent of y is 1 over square root of 3. And we don't have to write the inverse because I switched the two arguments. This and this are called arguments. Alright, so the and for tangent, y is in between negative pi over 2 and pi over 2, which means quadrant 1 and quadrant 4. Quadrant 1, quadrant 4. Quadrant 1 is always positive, the other one is negative. Oh, we're positive. So we know we are in quadrant 1. And we're taking the tangent of y. So the angle is y. And we get opposite over adjacent. And again, you should recognize this as the right triangle. 1 square root is 3, 2, where opposite 1 is 30 degrees. So once again, the answer is pi over 6, 30 degrees. Suppose you were asked to solve for y. Y is equal to the sine inverse of 1 over square root of 2. Well, any day of the week you can interchange these two. But then you better add the statement that y for sine inverse is between negative pi over 2 and pi over 2. That is quadrant 1 and quadrant 4. 1 is positive, 4 must be the negative 1. And we have a positive value. So we are in quadrant 1. The sine of angle y, so I put y there, is opposite over hypotenuse. Opposite over hypotenuse. And this is 1. This is a 45-45 right triangle. 180 divided by 4 is 45. So the answer is pi over 4. This problem here is very, very similar to somebody asking you to solve sine of y equals 1 over square root of 2. This has many, 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 many answers. Okay, one of which is pi over 4. But that's the difference between inverses and non-inverse equations. Inverses can only give you one answer. Okay. What if you were told that y is equal to the tan inverse of negative square root of 3? Well, this tells you, if you interchange these two, that the tangent of y is equal to negative radical 3. And y is in between negative pi over 2 and pi over 2. You're going to have to remember this for all the 6 trig functions. Okay. So, once again, this is, you're either in quadrant 1 or quadrant 4. Quadrant 1 is positive, the other one is negative. Oh, we're negative, so we're in quadrant 4. Remember, this is the same as over 1. So there's y. The tangent of y is, now let's not worry about putting the plus minus signs yet. It's adjacent over opposite. Sorry, opposite over adjacent. Opposite over adjacent. The 1 is going to the right, so it's positive, and the square root of 3 is going down, so that's the negative. Okay. I mean, just for the record, in quadrant 2, the tangent of y can be negative square root of 3. You'd have square root of 3 over negative 1, and when you divide these, you'll get negative square root of 3. So it's not just so clear which gets the negative and which gets the positive. Turned out that it was negative square root of 3 over 1. It could have been square root of 3 over negative 1. That could have been the opposite, and that could be the adjacent. But it wasn't in this case. Now, what is this angle? Oh, this is the 2 here. We're supposed to remember that this angle is pi over 6. It is, no, it's not. It's pi over 3 this time. This angle is 60 degrees, which is 180 divided by 3. But it is negative pi over 3. Do not give this answer, because that answer is, what's the matter? 360. That answer is 300. Okay, but 300, is that between negative 90 and 90? I mean, yes, it's bigger than negative 90, but it's not less than 90. Okay, so make sure you don't give that as an answer. What you can always do is find a coterminal. 360 minus 360, well, that's negative 60. Oh yeah, that's bigger than 90, but less than positive 90, so we'll use that answer. Okay, so did we answer the question? No. Now we will. Pi over 3. Let's do a few more. This one's interesting. What is the sine inverse of a half? Well, first let's figure out what this is. Let's call it y. Y is equal to the sine inverse of a half. Well, if I call this y, then we want to find out what the sine of y is. Okay, well, there's a rule that says you can change those as long as you don't put the inverse. Ooh, sine of y is a half. Done. That wasn't bad. I gave this a name. I called it y. And I even wrote down that statement. And then I said, oh, this is the same as sine of y equal to half. And of course, y is in between, blah, blah, blah. But nonetheless, we just want sine of y. We don't want to know what y is. We want to know what sine of this is. And if I call it y, I want to know what sine of y is. But once again, if I call that y, that means that the sine of y is a half, and fine, and y is in between negative pi over 2 and pi over 2. But I only want to know what the sine of y is. It is a half. Okay. let us try another one like that. What is the cosine inverse of 3/4? Well, if I call that y, then all I want to know is, what's the cosine of y? If I know what the cosine of y is, I write it down and I say I'm done. Well, if cosine inverse of 3/4, if I'm calling that y, I can interchange those two, and 3/4 is cosine inverse of y, and I'm like, oh yeah, I have to get rid of that. Oh, look at that. I have my answer. Cosine of y equals 3/4. Let us look at another one. Suppose you want to know the tangent of the tan inverse of -3. Well, if I call that y, I want to know what the tangent of y is. Well, if y is equal to this, oh yeah, then the tangent of y is -3. So I have my answer. What if I want to know the sine inverse of 2/5? Well, if I call that y, then I want the sine of y. So if y is the sine inverse of 2/5, and all I want is the sine of y, I'm done. It's 2/5. That is sine inverse of 2/5 is 2/5. What if you want to know the sine inverse of 17? Well, if I call that y, then I want the sine of y. So y is equal to the sine inverse of 17. That means that the sine of y equals 17. But this is nonsense. The sine of y can only be between plus or minus 1. So this has no answer. This has no answer. Now, what if I tell you this one, or ask you this one? What is the cosine of the sine inverse of 1/2? Well, this is an angle, we'll call it y. We want to know what the cosine of y is. Well, what I know is that if y is equal to sine inverse of 1/2, that means that the sine of y is 1/2 and y is in quadrant 1 or quadrant 4. And since it's positive, it's not in quadrant 4. Okay, so see here, this time I found out what the sine of y equals. That doesn't tell me what the cosine of y equals. So we have to go further. Not much further. The sine of y is opposite over hypotenuse. I mean, you can actually, okay, so we have this, and Pythagoras will tell you that's square root of 3. So now I know the cosine of y. It's adjacent over hypotenuse. The square root of 3 over 2. What if I ask you to find the sine of the tan inverse of -1? Well, let's call it y. So we want the sine of y. And once I know the sine of y, I'm done. So, it'd be nice if we can draw a right triangle with angle y in it, and then I can label all 3 sides, or at least 2 of the sides, opposite over hypotenuse, and I can find the sine. Well, if y is equal to the tan inverse of -1, interchanging, this tells me that -1 is the tangent of y, and y is between -pi/2 and pi/2. Y is in quadrant 1 or quadrant 4. Again, quadrant 1 is always positive. The other quadrant is negative. Oh, we want a negative answer. Okay, so we are in quadrant 4. So I go into quadrant 4. I draw my right triangle. The tangent is -1. So tangent of y. So 1/1. Since this is to the right, it's positive, and since this is down, it's negative, and we should know that that's square root of 2. Okay, and like I said a few moments ago, we just want the sine of y. Oh, you mean you want the opposite over the hypotenuse? And if your teacher tells you you have to rationalize it, there's your answer. Let us try one more at least. Suppose you were asked to find the sine of the cosine inverse of 2/7. Let's make it -2/7. So we call that y. So ultimately, we want the sine of y. Well, if y is equal to the cosine inverse of -2/7, that means that the cosine of y is equal to -2/7. And for cosine, y is in between 0 and pi, which means quadrant 1 or quadrant 2. Quadrant 1 is always positive. The other quadrant is negative. Oh, we want the cosine to be negative, not positive. So we're in quadrant 2. These are the exact questions you have to ask yourself. So we are in quadrant 2. And we know that the cosine of y is -2/7. -2/7. Hypotenuses are always defined to be positive. So it must be the adjacents that's the negative. Well, I want the sine of y. Well, that's not a problem. It's this number over that number. Oops, I don't know that number. So maybe it is a problem. Let's call it y. Y squared is going to be 7 squared minus 2 squared. The difference are squares. You add the two numbers that are being squared. You subtract the two numbers that's being squared. You get 9 times 5, 45. That's what y squared is. So y would be, well, it's the square root of 9, which generally I write as 3, times the square root of 5. So y is 3 square root of 5. 3 square root of 5 is, I apologize for calling it y. Why do I not like y? Because I already have something called y. Let's call it w. Let's call it something else. Okay? So w squared is 45. W is 3 square root of 5. And there's the answer to that one. Let us do one more. What if I come to tell you that the tangent of cosine inverse of 7/11, figure out what that is. Okay. So we call this y, and we ultimately want to know what the tangent of y is. So this here tells us that y is equal to the cosine inverse of 7/11. That means that the cosine of y is 7 over 11, and since that's positive, y, for cosine, y is either in quadrant 1 or quadrant 2. Quadrant 1 is always positive, the other quadrant is negative. Oh, we want the cosine to be positive, so this one wins. We are in quadrant 1. Okay. We're in quadrant 1, and we know that the cosine of y is opposite over hypotenuse. And what do we want? We want the tangent. So the tangent of y is going to be 7 over, I don't know yet. That's the opposite. I don't know what that is. But at least I can call it x. We know that x squared is 11 squared minus 7 squared. So 11 plus 7 times 11 minus 7 is 18 times 4, which I know is 72. Okay, now, before I shouldn't have multiplied that out. What I should say is, you know what? 18 is 2 times 9. 18 is 9 times 2 times 4. So that's x squared. Well, x is going to be, well, the square root of 3 I know. The square root of 2 I don't know. And the square root of 4 I know. Oh, so it's going to be 6 square root of 2? You better believe it. 6 square root of 2. And the tangent of this angle, the tangent of y, is opposite over adjacent. If you want to rationalize this, you multiply numerator and denominator by square root of 2, and you get 7 square root of 2 on top. Square root of 2 times square root of 2 by design has no more square root sign. This 2 times 6 is 12. And this can't be reduced, so maybe you should go back up to the top. Oh, we already had 7 over. Sorry. So it's, okay, so 7 over 6 square root of 2, and that's exactly what I simplified, and I got 7 square root of 2 over 12. And this completes the section on trig inverses. They're not bad at all as long as you know your definitions. You can't play the game without knowing the rules. And when it comes to trig inverses, you have to know the rules. What are the rules? They're right here. Okay? 1, 2, 3, 4, 5, and 6. How can you remember it a little bit easier? Sine inverse and tan inverse are the same, and so are, okay, okay, I said that. And cosine is this. Now, when it comes to the inverses, they're the same, except for cotangent. That is the inverse of sine. The reciprocal of sine inverse. That is cosecant inverse. They match. Look at that. Cosine, the inverse is secant. Secant inverse. Look at that. They match. So there's a way where I cut down in half of what you have to memorize. You memorize these two. These two come for free. And then you have to remember that tangent matches up with sine and cotangent matches up with cosine. You have to know these rules. Okay? Learn the rules. Lots of students, they say, oh, I can do this. And I'm like, okay. And then I say, what does this mean? And they're like, I don't know. Well, there's not much to understand when you memorize that. Okay, you interchange these two, and then you drop the inverse. And then you have to remember this second part. This second part is just as important as the first part, because it tells you what quadrant you're allowed to be in. That's the whole thing about inverse functions. You have to know what quadrants you're allowed to be in.